Alright guys, welcome to the channel. We're going to be solving question 43 from the second chapter of the Beer&Johnston textbook. And this one we have two cables that are tied together at point C. And we need to determine the tension in each of these cables, AC and BC. We can solve this question in two ways. We can either use trigonometry or go with X and Y components of each of these forces to find the answer. But let's just go with the trigonometry. But before that, we're going to draw the free body diagram. So we have the tension in CB, have the tension in CA, and obviously we have the weight of this 1600 kilogram mass, which would be mass times g, or acceleration of gravity, which we know on Earth we have 9.81 meter per square second. So we need to find the weight in here, 1600 times 9.81. That's going to give us Newton force. And if we want to use trigonometry, since we are in equilibrium, the sum of all these forces in X and Y has to be 0, or they have to cancel each other out. So if we consider this our TCB and this our TCA, the weight has to be in this direction in here in order to cancel out the other two forces. Actually, if we look at this, the resultant of each of these two would be the other one. So if we go with TCB and TCA, W would be the resultant. If we go with TCA and W, TCB would be the resultant. And if we go with W and TCB, TCA would be the result. So we need to figure some angles in here in order to use our law of sines. So we can call each of these angle in here. So if we want to find this one, that angle in there would be, we can call it alpha. Alpha is easy to find if we look at this right triangle in here. This would be our alpha. So if we want to find the alpha, we basically have the tangent inverse of the opposite side, which is 1100 over the adjacent 960. So we can find alpha pretty easy. So we will have the tangent inverse of 1100 divided by 960. That's going to be 48.89 degrees. We can also call this angle here beta, which if we look at it would be the angle that TCB makes with our y. So this is our beta, and again we have this right triangle in here. So our beta in here, we can do the same. We can go with the tangent inverse of the opposite of beta is 400, and the adjacent would be 960. So now we can find beta pretty easy too. So this time we have tangent inverse of 400 divided by 960. That's going to be 22.62 degrees. So now that we have these two angles, the triangle that we have in here, if we want to find the last one, we can call it theta. Theta would be 180 minus alpha minus beta, and that's because we know alpha plus beta plus theta is the sum of all the angles in a triangle, which is 180. So we have 180 minus alpha minus beta. Let's see what we get for that. So 180 minus 48.89 minus 22.62. So that's going to be 108.49. Now we can do our law of sines in here. And since we have all the angles, we should be able to find the TCB and TCA. So we have TCA over sine of beta, which is what we have in here, 22.62. That would be equal to W over sine of theta. We found W in here. Let's calculate that. 1600 times 9.81 So this will be 15,696 over sine of theta, which is what we have in here, 108.49 degrees, and this will be equal to T CB over sine of alpha, which is 48.89. So if we go with these two and cross multiply these, we can find CA. So TCA in here would be 15,696 times sine of 22.62 degrees over sine of 108.49. So let's see what we get in here. 15,696 times sine of 22.62 divided by sine of 108.49. So that's going to be 6,365.55 newtons, or if you want to report it as kilonewton, will be 6.37 kilonewton. And if we want to find TCB, we're going to cross multiply these two. So TCB in here would be 15,696 times sine of 48.89 degrees over sine of 108.49. And that's going to be, so TCB would be 12,469.84 Newton or 12.47 kilonewton, which would be the final answer for this question. We needed to find the TCB and TCA. So yeah, I hope everything was clear. Let me know if you guys have any questions. I'd be happy to help. And you guys take care. I'll see you in the next one.